So today we are going to continue with vector and scalar, and specifically we are going to be solving problems related to vector and scalar. Recall that we define scalar as any physical quantity that can be defined by magnitude only. Example is time, speed, and so on. And then we defined vector as any physical quantity that can be defined by both magnitude and direction. Example is force, velocity, acceleration. So we went ahead to discuss about addition of vectors, subtraction of vectors, multiplication of vectors. So two or more vectors are added if they are moving in the same direction. And if they are moving in opposite direction, you subtract the vectors. For multiplication of vectors, there are two ways vectors can be multiplied. A vector can be multiplied by a scalar, and a vector can be multiplied by another vector. So when a scalar multiplies a vector, the final answer will always be a vector. When a vector multiplies a vector, it could be the final outcome could be a scalar or a vector. Now, the final outcome will be a scalar when a vector multiplies a vector when you apply dot product rule or dot product method to multiply the two vectors. It will produce a scalar, and that is, let's assume that we have A vector A dot vector B multiplying themselves. That gives us magnitude A, magnitude B, cos theta. So this is a formula. And we can also multiply a vector by a vector using the cross product method. When we use the cross product method such as this, it becomes AB sine theta unit vector. Now, when we use this method to multiply two vectors, the outcome will be a vector. It will give you a vector. So now, let's look at some problems, exercises in vectors. So here we have a vector A given as 2i plus 3j. What is 3a? So this kind of question is scalar multiplying a vector. 3 is a scalar. A is a vector. So 3 is multiplying vector A. So the final outcome of this method of multiplication will give you a vector. So what will be our answer? So what to do here is 3 is going to multiply 2i. So our 3a becomes 3 times 2i plus 3j. So that will give us 6i plus 9j. So this is our answer. Now, if you look at it, the final answer is a vector as well, because scalar multiplying a vector will give a vector. Right. So let's look at another example. Here we are given two vectors, A equals 2I plus 4J plus 5K, and B, vector B, given as I plus 3J plus 6K. Find the product A dot B, and the magnitude of A and magnitude of B. Then what is the angle between them? So we start by finding the product A, vector A dot vector B. So this is a dot product. Remember that a dot product is also known as a scalar product, because the outcome of this kind of multiplication of two vectors will give you a scalar. So that is why another name for dot product is also a scalar product. So in this, we multiply the like components. So we have the components I, J, K. So I for I, J for J, and K for K. So vector A multiplying vector B, that will be 2 dot 1 I plus 4 dot 3 J plus 5 dot 6 K. 5.6 K. So 2 times 1 is 2 I. Now 1 is from B. Vector B is equal to I plus 3J plus 6K. The I has a 1 attached to it. That's where I got the 1. So I don't need to write vector B is equal to 1I plus 3J plus 6K. Since it is 1, I just leave it as I plus 3J plus 6K. So 2 times 1 gives us 2I plus 4J times 3J gives us 12. Gives us 12. 2I dot 1I gives us 2. I dot I dot I is equal to J dot J is equal to K dot K is equal to 1. So when I multiply 2I dot 1I, the i's multiply themselves, the number multiply themselves. So the number is 2, I dot I gives you 1. So that is why we have 2. Then 4J multiply 3J. The JJ multiplying gives 1. 4 multiplying 3 gives 12. And the next one is 5K multiply 6K. KK is 1. 5 times 6 is 30. So if we add them together, that will give us 44. So this is 44. This is a scalar. It is 44. So let's have our 44 somewhere here. Now, the next we are asked to do is to find the magnitudes of A and magnitude of B. So magnitude of A is given as square root of 2 square plus 4 square plus 5 square. So 2 square is 4. 4 square is 16, that is 20. 5 square is 25, that is 25. 20 plus 25, that is 45. Square root of 45 is the magnitude of A, and then magnitude of B is square root 1 square plus 3 square plus 6 square. So that is 1 square is 1, 3 square is 9, that is 10. 6 square is 36, that is 10 plus 36, that is 46. So we've solved for the magnitude A and B. Now, the next question is, what is the angle between them? So that will bring us to applying the dot product formula. A dot B is equal to A dot B is equal to AB cos theta. Now, we have AB as 44. We have AB as 44. We have A as 45. And we have B, magnitude B as 46. So to find the angle, we'll write that theta cos theta will be equal to vector A dot vector B over, you move this under this A, B, which implies that So that would be the 44 over square root of 45 square root of 46. So after you have simplified this, theta will be cos inverse of 44 theta will be cos inverse of 44 over root 45 times root 46. So that will give you the final answer. So I want you to simplify that and then send the answer on the comment page. Let's see if your answer is correct. So let's look at the next exercise. So here we are asked, two vectors are given as R, vector R equals 2I plus 3J plus 5K. And vector F is 3I minus 2J plus 4K. Find the resultant vector tau equals R cross F. Tau equals R cross F. So this is a cross product problem. So the first thing to do is to set out the equation. So R cross F will be equal to, we use the Saros method, matrix method. We use the matrix determinant method. Matrix determinant method. So I J, is a plus, is a minus, and K. So for R, we have 2, 3, J, and 5K. 5K. For F, we have 3 minus 2 and 4K. So this is a cross product, a vector multiplication, and the outcome will give us a vector. The outcome will give us a vector. So let's remember In this multiplication method, we follow the pattern I cross J is equal to a K. J cross K is equal to an I, and then K cross I is equal to a J. Is equal to a J. So we are going to multiply I and J. Now, for the start, we have I, so we need to find I. So if we are going to find I, we are going to multiply a J term and a J component and K component to get an I. So what are the J component? 3 and minus 2 are J component. 5 and 4 are K component. So we multiply diagonally and then subtract. So I will be 3 times 4, which is 12, minus, this is minus 2, diagonally, remember I said diagonally multiply across, minus 2 times 5 will give us minus 10. 12 is gotten from 3 multiplying 4, diagonally across. 3 times 4 is 12, minus, you find the difference, minus, then there is a minus in front of 2. So minus 2 times 5 will give minus 10. So that is why we're having a minus minus. So minus minus gives a plus, but we'll still come back. And so J has a minus. So to find the J, we need to multiply K and I to get a J. So I components are 2 and 3. I components are 2 and 3. K components are 5 and 4. So we multiply diagonally. So that will give 2 times 4. 2 times 4 will give us 8. Minus 3 times 5 will give us 15. Then the next component is K. So to get a K, we multiply I and J. I component 2 and 3, J component 3 and 2. So diagonally again, 2 times minus 2 will give us minus 4. Minus 3 times 3 will give us 9. So now we simplify our answer. This is 12 minus 10. So that will give us 12 plus 10. That is 22. So we have 22i. This is 8 minus 15. That will give us minus 7. Minus 7 times minus j. That will be a plus 7j. A plus 7j. Then here we have minus 4 minus 9. That will give a minus 13. Minus 13k. So this is our answer. So the resultant of the two vectors is given as 2i plus 22i plus 7j minus 13k. Now here you are asked to find the resultant. You could be asked to find the magnitude. So if you're asked to find the magnitude, so this will be R cross F magnitude. This is how to write it. And that will be magnitude. And that will be square root of 22 square plus 7 square plus 13 square. Now you may be asking, but we have minus 13k. Why do we have plus 13 square? Now, because minus square is a plus. So even if I insert a minus here, the square will affect this minus. So it will be minus 13 all squared. So this square will square the minus as well and make it a plus. So that is why in the calculation for magnitude, you will not see a minus. It's always a plus because the square will always turn the minus to a plus. So I expect you to use your calculator to simplify and then post the answer on the comment page. Let me see if you are correct. It's good to always participate. So let's move on to the next exercise. So here we have determine the value of the t from the given vector equation. Determine the value of the e from the given vector equation. So how do we do this? The way out is to take like terms. We have 5j minus tj is equal to 6j plus 3tj. So I will move 6 here, move minus tj here. So if I do that, I will have 5j minus 6j is equal to 3tj plus tj. So 5j minus 6j will give us minus j. And 3tj plus tj will give us 4tj. Now if I divide through by 4j, isolate t and divide through by 4j, that will give us minus j over 4j. So j cancels a j. I'm left here at the numerator with 1. So t becomes 1 minus 1 over 4 minus 1 over 4. That is our t. All right, so let's move on to the next exercise. So we are given two vectors, A and B. The component form of A is 5i plus 7j minus 4k. And B has a vector 6i plus 3j plus 2k. We are asked to find A plus B, vector A plus B, and vector B plus A. And then vector A minus B and vector B minus A. Right, so what is AB? A plus B, vector A plus vector B. Now remember, when you are adding two vectors, you add them by their similar components. So you add I and I, J and J, K and K. If you want to subtract, you do the same thing. I and I, J and J, K and K. So A plus B. So the first component is 5 plus 6i. Then the next component is 7 plus 3j. And then the next is minus 4 plus 2k. So 5 plus 6 is 11i. 7 plus 3 is 10j. And minus 4 plus 2 is minus 2k. So vector A plus B is 11i plus 10j minus 2k. That is vector A plus B. Now, vector A plus B will also be equal to vector B plus A. Vector A plus B will be equal to vector B plus A. So both of them will have the same answer. Vector A plus B is equal to vector B plus A. So we move on to the next, which is vector A minus B. vector A minus B is not equal to vector B minus A. Or vector A plus B is equal to vector B plus A. So let's find vector A minus B. So vector A, I is 5. Five minus 6I is equal to minus I. So 5 minus 6 is minus 1. So instead of writing minus 1I, you just write minus I. Then 7 minus 3J is 4J. And minus 4 minus 2K will be equal to minus 6K. So vector A minus B is minus I plus 4J minus 6K. Minus 6K. Good. Now let's also find vector B minus A. Vector B, which is 6 minus 5I, and 3 minus 7J, and 2 minus 4K. So this is I minus 4J 6K. So B minus A is equal to I is equal to I minus 4J plus 6K. Now, if you compare B minus, if you compare B minus A and A minus B, you will notice that A minus B is equal to minus minus B minus A. So A minus B, vector A minus vector B is equal to minus B, vector B minus vector A. However, if it is a plus, A vector plus vector B is equal to vector B plus vector A. So addition of vector is commutative. Commutative obeys, that's addition of vector obeys commutative law. Commutative law simply means that uh, the manner in which the vectors are added are not will not affect the outcome of the vectors addition. So the manner in which the two vectors are added will not affect the outcome. So if I add A to B, it's the same as adding B to A. But subtraction is not commutative. Subtraction of vectors, two vectors, is not commutative. So note that. Let's move on to the next exercise.
Sir, we can't see the slide in anymore.
I'm coming.
Okay, sir.
Yes. I'm trying to bring up another slide. Okay. Let's continue. So here we are given question. So what is the direction cosine of vector A is equal to 2i plus 4j minus 5k? So if you recall, direction cosine means for 2D vectors, that is two-dimensional vectors. For instance, if you are given vector A and vector B, the angle between them, we can use AB cos theta to find the angle between them. We can also use A cross B to find the angle between them. That use cross product or dot product to find the angle between them. But when the vector is a 3D vector, such as this, and you have to find the direction of cosine, what they are asking you to find is the angle each of the components, that is I component or x axis, y component, j component or y axis, k component or z axis. The angle each of these components or axes makes with the resultant vector. That is what we are asked to find. And if you recall, we said in that case, we are going to look for alpha, that is cos alpha, cos beta, and cos gamma. So cos alpha is the angle between the resultant and the x-axis. Cos beta is the angle between the resultant and the y-axis. And cos gamma is the angle between the z-axis and the resultant vector. So the first thing to do for this is we need to get the magnitude. The magnitude is the resultant. So magnitude for A will be square root of A, that is 2 square plus 4 square plus 5 square. 2 square is 4, 4 square is 16, 16 plus 4 is 20. 5 square is 25, 25 plus 20 is 45, so square root of 45. So that is our A. So cos alpha, angle between the magnitude and the S component. That will be, the S component is 2. So that will be 2 over root 45. Cos beta is the angle between the Y component and the magnitude. What is the Y component? Y component is 4. So that will be 4 over root 45. And then the last one, which is cos gamma, the gamma is the angle between the Z component and the resultant. What is the Z component? 5. Minus 5. So that is minus 5 over root 45. And you write it up there. So cos gamma will be minus 5 over root 45. So if you come back to these options and look at the way the question and the answers are arranged, we have first 2 over root 45, second 4 over root 45, and third minus 5 over root 45. So the answer is B. B is the correct answer. B is the correct answer. So let's move on to other examples and exercises. Okay. Here, we are asked to find the angle between vector u and vector v. So the first thing is write down the formula, which is u find u dot v is equal to uv cos theta. So the angle we are asked to find, so that would be theta is equal to second function of cos u v over uv. So what is u dot v? U dot v is simply multiplying vector u and vector v, but in this case, when you are multiplying, you multiply the components. So uv, let's find them separately. U dot v is, come to here, we have I, J, K. I, J, K. So that would be minus 2 times minus 4. That is 8. Then 3 times minus 3, that would be minus 9. Minus 1 times 4, minus 4. So the sum will be that is minus 1 minus 4 will give us minus 5. Minus 5. Now, what is the magnitude of u? Magnitude of u is equal to square root of vector u components, which is 2 square plus 3 square plus 1 square. So that gives us 14, square root of 14. Then magnitude of v will be square root of 4 square plus 3 square plus 4 square again So that is square root of 4 square is 16, 16 plus 16, 32, 32 plus
plus
9. That is 41.
40.
41. So if we substitute these values here, that will give us theta. Theta will be equal to second function of minus 5 over square root of 14 times 41. So you can use your calculator to find out the answer. So the answer should be 102 degree.
102.
Yeah, that is correct. So let's move on to more examples. Yes, the time permits. Mind you, it's also on YouTube. So when I'm through, some of you that did not join very early, I will
Yes,
send the
sir.
YouTube link to your class rep so that she will forward it to you people so that you go back to the YouTube. And now you need to click the subscribe button so that even without getting the link for the class, once I come online, immediately you get a prompt that the lecturer is online. So you don't need to wait for any information from anybody. Once I come online to start teaching, you will get the prompt.
Sir, sorry, sir, but we want to know from what time does the class always commence? Is it from 12?
Not necessarily 12. It's supposed to be in the afternoon by 4. But
Oh,
because
yes.
at that time I'll be engaged. I won't be able to have the class. That is why it's okay. Let me have the class, then send the YouTube link to you people. So when it's that time, if the class
Okay.
referred, you go online, just have the class. It will be just
Okay. Okay.
recorded and everything.
Okay, sir.
At that time won't be
Okay,
chance.
okay, 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 okay. Yes, sir. Yes, sir.
So here we are asked to use the cross product method to show if U cross V is orthogonal to both U and V. Orthogonal means that the angle between the two vectors is 90 degrees. That is what orthogonal means. So what we expected to do is to find the angle, just like the previous slide. We had to find the angle between the two vectors, and we found it to be 102. So in this kind of question, you are indirectly asked to find the angle, but they are not. It's not direct, but the way to solve it is to find the angle. So when you find the angle and the angle is 90 degrees, then it is orthogonal. If the angle is not 90 degrees, then you respond that the angle is not, or the two vectors are not orthogonal. That is what this question is all about. So now, to find the cross product of two vectors like we did before, you set it up the way it is, U cross V, then I is a plus, J is a minus, K is a plus. Then U takes the first line, which is 6 minus 1 minus 2. Then V takes the second line, which is minus 1 minus 4 and 2. So you first of all set up the equation like this. And then the next step is to multiply across the diagonal and find the difference. Remember that this is a cross product, which means that you are not going to multiply by components like we did for dot product. For a cross product, when you multiply I dot I cross I, it gives you a zero. I've explained why it will give you zero, because I dot I, that is similar components, it implies that the angle between them is zero. And for a cross product, the formula is U cross V is equal to UV sine theta. So if I multiply I and I, it means that the angle between them is zero, because I is an horizontal vector, another I is an horizontal vector. There are two horizontal vectors. So of course, that means that they are moving in the same direction. The angle between them will be zero. Sine zero is always a zero. But if I multiply two adjacent um, components, for instance, or two perpendicular components, y and x. Y is vertical, x is horizontal. So the angle between them is 90. So sine 90 is equal to 1. So that is the rule. So coming back to this example, so we cross to find I. It means I must multiply j and k to give me a I. J and k. So what j components are these, k components are this. So I'll multiply diagonally this way and this way to find the difference between them to give me an I. So let's go on. So if I multiply this, that is minus 1 times 2. Minus 1 times 2 will give me what? Minus 2. Minus, if I multiply this, that is minus 4 times minus 2. That will be plus 8. This is I. So the outcome of this is minus 10I. Then minus j. To get a minus j, it means that I will have to multiply a k and I, a k and I. If I multiply a k and I, it will give me a j. So, which means I'll multiply this and this to give me a j. So now, diagonally, this way, and this way. So 6 times 2. 6 times 2. 6 times 2 will give me 12. 6 times 2 will give me 12 minus this, which is minus 1 times minus 2. That will give me a 2.
2.
So 12 minus 2 is 10. So this will be minus 10G as well. So the next one is to find my K. So the same way we apply the same method. So to find a K, it means I multiply I and J. I and J to give a K. So this is I and this is a J. If I multiply them both, it will give me a K. So I take the diagonal multiplication. 6 times minus 4. 6 times minus 4 is minus 24. Minus 24. And then the next diagonal is minus 1 and minus 1. Minus 1 times minus 1 is plus 1. So K will be minus 24 plus 1. That is minus 23 K. So let me write 12. So K, we have 6 times minus 4 gives us minus 24. Then we have minus 24 minus 1. So that will be minus 25K. So that is what you see here. Minus 10I minus 10J minus 25K. So that is the first part of the question. The first part of the question says, find the cross product of vector U and vector V. So we have done that. Cross product of vector U and vector V is minus 10I minus 10J minus 25K. Now, the next part of the question says, show that U cross V is orthogonal to both U and V. So to do this, what we have to do is we assume that U cross V is a singular vector. So let's rename U cross V as vector W. So vector W, U cross V is equal to vector W, which is equal to minus 10I minus 10J minus 25K. So to show that W, which is U cross V, is orthogonal to both U and V, it implies that we'll have a setup such as W dot U is equal to W U cos theta. Then W dot V is equal to W V cos theta. So now when you set it up this way, what we are expected to do is to find theta in both setup. So if theta is 90 degrees, then it means that they are orthogonal. If it is not 90 degrees, they are not orthogonal. So W is minus 10I minus 10J minus 25K. Now, what will be W? Let's take this first one. That is this. Let's take it one after the other. So W dot U simply means you multiply W component and U component. Then W means magnitude of W, and then U means magnitude of U. So at the end, you are going to set up your equation as theta is equal to second function cos W U over, let me write it somewhere that is spacious here. So theta is equal to second function WU over W dot U over WU. So you are going to apply the same formula for W dot V. So what is W dot U? You multiply, it's a dot product, so you multiply them component by component. So W, I component is minus 10. For U, I component is 6. So minus 10 times 6 will give us what? Minus 60. Then for J, we have 10J times 1J. That would be plus 10. Then for K, we have minus 25K times minus 2K. That is a plus 50. So this will give us what? Minus 60 plus minus 60 plus 10 will give us what? Minus 50. Minus 60 plus 10 is equal to minus 50. Plus 50 would be 0. Minus 50 plus 10 is minus 50. Plus 50, that would be 0.
0.
So if W, that is this, the numerator is 0. It means that the answer is, everything inside is 0. So theta is equal to cos second function 0 over this WU. So since the numerator is 0, everything within this bracket will be 0.
0.
If everything is 0, second function of cos 0 is what? 90. Second function of cos 0 is what? 90. Because cos 90 is 0. Cos 90 is 0. So second function of cos 0 is 90, which means that W and U are orthogonal. W and U are orthogonal. If you apply the same method, multiply V and W together and simplify, you will also get 0 at the numerator. Yes, so let's try it and see. So we have minus 10 times minus 1 will give us 10. Then minus 4 times minus 10 will give us 40. Then 2 times minus 25 will give us minus 50. So 10 plus 40 is 50. 50 minus 50 is 0. So the same, since the numerator is 0, everything within the bracket will become 0. So second function of cos 0 is equal to 90, which means that the two vectors are orthogonal. That is, U and V are orthogonal to their cross product. They are orthogonal to their cross product. So let's see if we can take one more before we end for today. So here we are asked to calculate the resultant of the forces acting at a point in the figure using resolution process. Using resolution process. Now, to solve this, what you are required to do here is resolve each of these, one, two, and three. We have to resolve them all to horizontal and vertical component. However, for this, you will not need to resolve because there is no angle. It is on the vertical component. So you take it that way. But for this, you have to resolve to horizontal and vertical component. So the horizontal component will be 100 square root of 2 cos 45 degree. The vertical component will be 100 square root of 2 sine 45. So for this also, you do the same. You find the vertical component and the horizontal component. So the vertical component will be 980 root 2 cos 45. I mean sine 45 degree. Because this is 45, this is 90, it means that this will be 45 degree as well. Because angle on a straight line is 180. So the horizontal component will be 980 root 2 cos 45 degree. Now, after you have resolved to vertical and horizontal component, you now add all the vertical components together and all the horizontal components together. Now, in this first quadrant, that is here, we have this as the horizontal component. Here we have this as the horizontal component. Both of them are in opposite directions. So their resultant will be subtraction. If we say this is A2 and this is A1, it will be A1 minus A2. A1 minus A2. If we say this is B1, B2, and this is B3. Here, B1 and B2 are both upward, above the x-axis, upward in the north direction. So we add them together. B3 is below, so we subtract. So we can write an expression for it as B1 plus B2 minus B3. So coming back to A, A1 is 100 times square root of 2 cos 45 minus 980 square root of 2 cos 45. So that will give you answer for A. Answer for A. Then that is horizontally, that is x-axis. Then for the y-axis, vertical component, we have B1, which is 100 root 2 sine 45 plus 980 root 2 sine 45 minus 1960 minus 1960. So that will give you component resultant vector for the vertical component. So I don't have calculator with me. So this is what I was explaining to you before. So when you have done all that, you are going to find the resultant, that is the magnitude of the component. So when you find the magnitude of the component, that will give you what the answer that is written here. Remember that by the time you find the resultant of vector A, vector B, you are going to find the magnitude, which is applying the Pythagoras theorem. Find the square root of the x component square plus y component square. And that will give you this answer, the final answer. So you have questions and answer here to practice with. If you have any question, you can put the button to the forward the